Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
This is GOTO Unscripted. We're at GOTO Copenhagen. My name is Jeroen Engels. I'm joined with Andrew Kelley. So I'm a software engineer at CrowdStrike. I work primarily with Elm. I like to, in my spare time, work in the Elm linter, which is called Elm Review, which I presented at the conference. Andrew?
Hello. As Jeroen mentioned, my name is Andrew Kelley. I am the president and lead software developer of Zig Software Foundation. And
that sounds so much more fancy than what I had.
Well, I heard that you have a thirst for linters.
I do. And I heard that you don't use a linter. Yeah, the static analysis tools is just something that I find very enjoyable because I've been a JavaScript developer before, and I was always kind of frustrated with all the problems that popped up with the code. So I worked with ESLint on trying to figure out what rules can we enable to make sure that these problems don't end up in our production code base. And at some point I started looking at Elm, which is basically a very good, fresh, new perspective where all the problems that I had with ESLint or with JavaScript didn't appear anymore. But I still figured it would still make sense to have a linter for Elm, even though almost none of the same problems apply.
Does Elm offer any powerful refactoring tools?
You mean, for instance, in IDs or?
Yes. For instance, Java developers enjoy very high-level abstraction refactoring tools, such as they can highlight a block of code and say extract into method.
Yeah.
Or they can even take a function and just reorder the parameters, and it will update every call site at once.
Yeah.
Do you have anything like this for Elm?
We have to some extent, but definitely not to the same level. But it's just a matter of someone needs to be passionate about it and tackle those issues, because we have so much more knowledge about what the code is doing in Elm compared to Java or other languages, in my opinion, that it's all doable. So it's just a matter of someone needs to do it. We have some refactorings, like we can extract variables, we can rename things, but that's about it for now. Well, and more of it.
That's pretty nice.
What do you have for Zig? Do you have a good integration with, I think VS Code is the one that supports Zig the best? Yeah,
the best we have for now is a third-party language server protocol implementation.
Yep.
But it's kind of a best effort implementation, and third-party. Doesn't come with the compiler. It can break separately.
Is it best effort because you're not? The focus hasn't been there yet, or?
Yeah, I mean, I don't work on it. Someone from the community works on it. They do a great job, but shout outs to August for working on that. But there's only so much you can do without it being integrated with the actual type information that the compiler has. But I will say that the investment in that we've done for the future is designing the language without. With conditional compilation being a first-class part of the language rather than being through textual preprocessor.
What do you mean? What does that change?
So if I have an IDE for C or C++ code, And part of my C library API is that one of the functions is just a macro that gets textually replaced.
Okay.
Then, the refactoring tools, they don't know how to deal with this because it's not one language, it's two languages, and one of them is text-based concatenation, and it doesn't know how to.
Yeah, if your language if it was somewhat standard that you had macros that were being replaced all over the place, well, then the tool could analyze it. Well, okay, well, we know that there's this macro in the code base, therefore it will be replaced at this location, this location, this location. But if those macros get too custom, then it's really hard to analyze, right? And therefore you lose all the guarantees about, oh, well, I can't see any GOTO instruction here. Therefore, I know that it's not doing anything weird. But if you have macros that change the code, then you lose that kind of guarantee. Right?
Yeah, you lose that kind of guarantee, or you have to execute the preprocessor and then assume that one set of defines is true. But maybe if your build system changes the option, then this other if-def defines it the other way, and so then you try to do a refactoring tool, but then it's wrong for all the places where the other definition would be activated.
Yeah,
you can't you can't solve the problem.
And also you have to point the error at some point, right? At some location in the code base. But if that code base doesn't exist because that's the result of applying the macro, then what are you pointing at? Well, so yeah.
Yeah, that's a good point. Do you want to talk about errors versus warnings?
Oh, sure. So during my talk, I talked about severity levels. So some linters, they allow you to specify for each rule how you want them to influence the exit code of the linter. If you have a rule that is set to be an error, then whatever it reports will cause the linter to exit with an error code, meaning that it will cause your test to fail, and you will be notified and you will have to fix it. And then you also have warnings, which do not cause your linter to exit with an error code. And as I said during the talk, that doesn't really make much sense because you're trying to enforce a rule without trying to enforce it. Because you enable a rule and you say, well, if I want this rule to be enforced, but I also don't want it to cause the test to fail, so therefore it's not enforced. And that just doesn't make sense.
I completely agree. Okay, but let's try to explore this idea. So you talked about false positives, and you gave your example of your favorite linter rule, which I also happen to have as a favorite, which is dead code, unused variables, unused functions. Get rid of them.
Yeah,
love that. That one is not one that has false positives. But what about a linter rule that is useful, but it fundamentally must have false positives in it? Can you think of any? Or perhaps do you think that there should never be this kind of linter rule?
Yeah, so code smells are usually those kinds, right? We always say it's code smell because it's probably a sign that there's something bad about it, but we don't know for sure. Sometimes it's good, just like cheese. It smells bad, but in some cases, it's good. So yeah, code smells, whatever that might be for your language or your ecosystem.
If it smells like a stinky foot, could be a bug, could be blue cheese.
Or a stinky foot.
Or a stinky foot.
And a stinky foot is better than no foot.
Oh, I see. I see your point. Your point is that maybe it is smelly code, but there's no other way around it. This problem is hairy, and only the stinky foot has hair on it.
Potentially, yeah.
I see. Yeah.
Yeah.
Okay. This analogy has gone quite far. But do you have an example of a code smell lint? I'm going somewhere with this. I mean, I'm going to ask about disable comments, but I want to come up with an example first that we can examine.
Yeah, the thing is I don't have too many examples because when we have too many counterexamples when we're trying to think of a rule, we tend to not implement that rule.
Right.
So, yeah, it's a bit tricky for me because I've just didn't think about those
for Elm, right?
Yeah.
But what if you're stuck with a more legacy language, C, C++, JavaScript? So maybe the language is not as nice, and so we might have more smells.
Yeah. So yeah, in those cases, for instance, you could say, well, you should never access anything on null, right?
Okay.
And if we imagine we're targeting JavaScript and not TypeScript, we don't have any information about whether something is nullable or not. Well, then you pretty much have to report everything, right? If you don't say, oh, if this parameter is not null, then you can do this. If it's null, then you do something else. But if you don't have those checks, then you're going to have to report every usage of it. So you see what I mean?
So what is the lint? The lint is...
So yeah, let's imagine the lint is, we want to report any field usage of a potentially null value. Like if you do a.b, then if we haven't checked that a is null or not null.
Well, what if a comes from the function parameter and we're expecting it to never be null on?
How would you tell it that it shouldn't be null if you don't have types?
Oh, I see. So you would need to assert that it's not null, and that assertion would make the linter error go away.
Yeah.
Okay. This sounds okay. It sounds kind of nice, actually.
Yeah, but you would have a lot of false positives because well, this function is never called with a null value. We know it because we have asserted before. But because the linter doesn't know that, it has to force you to reassert that it's not null.
Well, that answers my question, because the next question I was going to ask is why not? I mean, you mentioned that you think that there's never a reason to have a disable comment for a linter.
I wouldn't say never.
Oh, not never. Okay.
But it should be very rare.
Very rare. And you already showed that in this case, it could be disabled not with a comment, but with an assert. Yeah. And that's better. And that doesn't count as a disabled comment, right?
No, that is you pushing towards better code or code that reads more like what you want, right?
That's very nice, yeah.
Yeah.
I have to admit, during your talk, I was thinking to myself, there has to be lints where you need to disable them, but now that we're trying to think of any, I'm coming up dry.
Yeah, in some cases it will be like, we don't have the information that we need, but people can always change their codes in a way that the linter can understand that, hey, here there's no problem because we added an assert, or we added an if condition where we say, is this value null? Things like that. So whenever you get a linter report, you always have to change your code, be it through a disable comment or through changing the code.
That makes sense. Do you want to talk about autofix or prompts, fix prompts?
Sure, yeah. So what I talked during my presentation was that linters, they tend to have this feature where they automatically fix some of the issues, which is a very hard thing to do. Like, I don't know if you've written any linter rules in your career, but writing a linter rule that does the right thing always is very hard. It takes a lot of gathering context, gathering information, and do some logic to figure out, is there a problem or is there no problem? And writing a fix for it is a lot harder because you need to gather a lot more information to make sure that you don't change the code to something that will not compile, that will break, maybe even that doesn't look weird code style-wise. Like the indentation still needs to be all right.
Right. And you might not have type information.
We might not have type information. So yeah. So fixes are super useful, but they can be done in a trustworthy or untrustworthy way. So the example that I took was for ESLint, where I said if you run ESLint --fix, it will fix all of the issues that it can fix automatically. And the problem is that if you do that on a new project or you just enabled a very large a new rule that changes a lot of things, then you have a very big diff. And that diff can be very hard to analyze. And the problem is that the linter doesn't tell you which errors were reported, and it doesn't tell you how it tried to fix each individual issue. And therefore, you have a lot of trouble figuring out whether the change was safe and whether you can push this to production. So what I do with Elm Review is, when you run it with the fix flag, it prompts you for every error with a fix. Like, it tells you all the details, like, this is why I'm reporting this issue, this is what you did wrong, but I think I can fix this. Would you like to accept this change, yes or no? And by doing this process of prompting for every error, we can get to trust the tool, because we see that it's doing the correct thing. We see, well, it suggested this, it reported this problem, it suggested this fix. That looks pretty good to me. And if I see that it does that 100 times in a row, I start to trust it. And only when you trust the tool, then we have an Elm Review fix all feature to fix all the issues in one go and then prompt you.
Yeah, that's nice. I have to admit, though, I found myself thinking while watching your talk on this that you showed a 600-line diff, and the alternative is a command line prompt that shows you a small diff, I don't know, 100 times that adds up to 600-line diff.
Yep.
And for me personally, I actually would rather pick the 600-line diff, because on one hand, it's nice that the smaller prompt will give you the context, but it's going to be the same issue over and over again, right? It did the same fix, the same fix, the same fix.
If it's the same rule, yes.
Yeah.
If there are, like, if you have 200 rules that each do a different thing and fix the issue or fix their issue in different ways, then those compound. You have one transformation, then another transformation, then another transformation, and the code, the beginning code and the end result code, they look very different.
Right.
So you don't know, like, how many errors were reported, how many fixes were applied.
Because it might be multiple fixes in the same lines.
Yes.
I understand, yeah.
Yeah, and so in that case, it gets complex. If you only have a single rule that reports all these issues, go use fix all. If you think that looking at a giant diff is good enough in this case, go for it. That's why you have Elm Review fix all.
So maybe just if scrolling through the diff is fastest and the changes are simple enough, then perfect.
Yes.
But it's nice to have that advanced option for when it's a little more tricky to understand what just happened.
Yep.
At least we have this tool that can break it down, so you're never just trying to trust. You don't have to trust the tool. You can have the tool explain to you why is it doing what it's doing.
You don't have to trust the tool.
Right. I see your point.
Yeah. You don't trust it. You submit to it, is what I'd like to say. Yeah. But because imagine you're a junior developer, you just started using JavaScript, you just start using ESLint because someone told you it was good, and you run ESLint fix, and then it changes the code in very different ways, and you have no clue. Like, I barely knew what the code was doing before. Now I don't know what it's doing now.
Well, yeah. If I'm a junior developer, I'm going to assume that the tool knows better than me, and accept it blindly, right?
Yeah.
I mean, I would just read the diff. But if I was a junior developer, that I would just assume that someone else knows better than me and just say yes, 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 yes.
Yes, but that's not always correct, right? Because the fix is just a suggestion of a fix.
Right.
Yeah. For instance, if you have an unused variable, the fix is to remove it, right? But potentially it's the code that I just wrote, and the correct solution to that is to start using it somewhere.
Right.
So that's also a reason why I like to push towards prompting for every fix, is to notice, oh, there's something that I did wrong and that the tool won't help me with.
Yeah.
So the tool is not doing something wrong, but there are sometimes better solutions to the problem.
Okay, so here's a question. So you've written Elm Review, and you have you've put a lot of thought into the workflow of using linters. Okay, so I've created the Zig compiler, and the Zig compiler has more features than most compilers. It's not a bare bones compiler. I mean, it has formatter built into it. It has unused variable errors. And in a branch, I haven't merged it yet, but I have this -- fix feature in the compiler directly, not a separate linting tool.
Yeah.
So the topic I wanted to bring up for you is, can we talk about the trade-offs of having linting errors, so stuff like removing unused variables, maybe other things like that too.
I'm sure that the C compiler has a lot of warnings that you don't have.
Yeah, we do not have warnings.
Okay.
Only errors.
Okay.
So
sounds good to me.
Sounds good, right? Okay, but we also don't have a linter.
Yeah.
And so people do find it annoying that when they're trying to iterate quickly, they are not allowed to have unused variables. And so, I mean, one obvious choice is just separate the linter step from the compilation step, and that's the workflow that you've described.
Yes, I think that's the way to go. Yeah.
Okay, so then here's a downside though. If I'm looking at someone's code, then maybe they didn't run the linter step, and so I'm looking at it and I'm seeing this function and I'm trying to understand it, and it's annoying because it doesn't make sense. Why is it doing this? Why is it doing this? And then 30 minutes later, I realize it's never called, and that explains it, right?
Yeah.
So it would have been nice if that linter guarantee was there, but they just didn't run the linter yet because it's not Tuesday. I don't know.
Yeah.
You see what I'm saying?
So in which context are you looking at it? Because that changes how you think about it as well. For instance, if you have a pull request and the tests are green, and you look at the code, then you will still have the guarantee, well, all the code that is there is used because the linter has run. If you're looking at code that is still being written, like you're pairing with someone, or someone says, hey, I have a bug, can you help me fix it? Then sure, the code might be unused, but for a good reason, because they're still working on the function and they may want to clean it up later. So it really depends on the context of when you're looking at the code, I think. You could also say, well, if I want to look at any Zig code on the internet, just like in a GitHub gist or something, then I want to know whether all the used things are used or not. But someone might paste some non-compiling Zig code as well.
That's true.
So
yeah.
I think if you don't have a CI running next to the code that you're looking at, or you just run the test, then you don't have any guarantees anyway.
I think that's an interesting point. So yeah, one kind of takeaway, at least for me, from this conversation is that linting is fundamentally related to the idea of continuous integration.
Yes. Like if you have a linter, but you don't enforce it in your CI or in your test suite, that's no use. It's just like having warnings for everything.
Right, so we have this phase of the development cycle. There's the development phase, and then there's the integration phase. And even if you have continuous integration, that's still a separate phase. That happens when you make the patch set to send.
Yeah.
That's interesting.
Yeah.
What about, okay, so I'm just brainstorming here. Are there any projects that justifiably do not have a separate integration phase?
So when you say integration phase, you mean specifically what?
Well, I'm calling the part where you run the CI tests. Maybe you make a pull request, and then the tests run automatically. You know, before you merge it. That's the integration phase.
Okay.
Right. The development phase would be on the local developer's computer before they submit the patch.
So are there any projects where an integration phase doesn't make sense?
Well, where the team justifiably does not have an integration phase. So I'm not trying to make a point. I'm actually just musing out loud. Like maybe, I don't know, maybe video game companies don't have an integration phase. Or maybe their integration phase is you play test the code. I don't know.
Yeah, I think there might be two use cases that I can think of. One is when the product or the project is very early in its development phase, and people don't care about the code quality. Like we've seen a talk from Henrik about the fact that code quality should be done after the prototyping, because you want to iterate, you want to explore ideas, and afterwards, then you can think about code quality.
But then you could just not do the linter step on that case as well.
Potentially,
right.
Yeah. It's an approach that I haven't tried out, so I'm curious to know how it would work out. Maybe you would only enable some of the linter rules, and when for the code that has been should be in the code quality phase, then you enable more rules for that specific part of the code base. Maybe.
Well, that was pretty interesting. Did you have any other topics that you want to examine?
Yeah. So from the little I've seen from Zig, it cares a lot about guarantees. Like you told me, like I see some Zig code, I want to have the guarantee that this function here is used, that this function compiles, that it will not crash, stuff like that. It's things that are enforced by the compiler, potentially by a linter or a code formatter. And I feel like the same happens with Elm. Like we care a lot about guarantees, about adding constraints that give us a lot of things in return. And I feel like that's something that is quite recent-ish. So I've worked with JavaScript before where you had almost no guarantees. You've worked with C where you have a lot of things can go wrong. And I feel like the languages that pop out recently, especially the ones that come with the functional programming paradigm, they care a lot about giving guarantees about the code, about how it will execute. And I feel like, is there a trend to add more guarantees in languages? Is that something that we now all care about? What do you think?
I actually do not think that that's the case, because I do see a lot of contemporary new languages which they don't seem to focus on it too much.
Do you have any examples?
Oh, you're going to make me burn another project, huh? I will give an example. So the example I will give will be Nim. So Nim's emphasis is on flexibility and power. And so you can do some really impressive things with the Nim macros. Like I think that they pride themselves on having a lot of the core syntax, such as just like plus and minus and division and things like this, defined in the standard library. You can also implement async await in userland in Nim, which is pretty cool, right? It's pretty powerful that you can do that. That's a fundamental transformation of the control flow of a function to make it async await. Yeah. And they do that with like the powerful metaprogramming tools that the language exposes. You see where I'm going with this, though. If you're reading a function, does it use a powerful metaprogramming technique to fundamentally change what that function does? Maybe. You don't have that guarantee.
It doesn't say it explicitly. It does it implicitly.
Ooh, I don't know enough. I don't know enough, but I mean, you could just be scrolled down and you're not looking at the top of the function or something like this. Do you see what I'm saying?
Yeah.
Whereas with Zig, it's a trade-off. So we don't have some of these powers. Like you can't implement async await in userland. It's part of the language syntax.
Yeah.
But if you're in the middle of a function, just looking at a piece of code, you have a lot of guarantees that if you see this variable and you see the definition of that variable somewhere else on outer scope, it's the same thing. It's not shadowed or redefined or something like this. So, yeah, I think there's my my crafty. I'm not trying to burn Nim, but there's an example for you language. Yeah.
So what do you care about having so many guarantees?
This preference. I mean, it's just my subjective opinion is that I like to make reading code the easiest thing to do with the language. We see this sometimes. sometimes people use advent of code to learn Zig, and it doesn't really go well for them because advent of code is write-only code. You're never going to come back and read it again.
Yes.
You don't care about it. It's a small, 20, 30 line program, and it's write only. But I mean, Zig code is almost read only. It's obviously it's not read only because you have to edit it, but Zig code is meant to be maintained. It's meant to be refactored, moved around. It's meant to be a large code base that you're trying to manage the complexity of.
Yeah.
And
secure and safe.
Yeah, all that good stuff.
Refactor it and it will still work.
Yeah. And this, I have to tell you, so I have a lot of our linter errors, I guess you can call them, like unused variables. There's categories of errors. So some require the type checker, but some can operate directly on a file. They don't need, it doesn't matter what flags you pass. It doesn't matter what target you pass. Like we know if you have an unused variable just based on the file alone, nothing else. So I have this on save. So when I save a file in Zig, it runs the formatter, and it will give me like an error list for unused variables, for use of undeclared variables, like a certain class of errors that are detected on like just a file level. Those are all reported just instantly.
Yeah.
And I love it so much for refactoring because all I have to do is just grab a block of code. I can just cut and paste code. I don't even read the code. I just cut it, I paste it, I put it somewhere else. Or if I want a piece of logic from this function, I just move it.
Yeah.
And then I get errors for, it's almost like I reached into a robot and just like grabbed their arm, and then I just put it on another robot. And then I just get an error for every wire I just need to like reattach to the, that's exposed. And then it works. Yeah. Because of all these guarantees.
Yeah.
I love that, just the ability to move large pieces of code around.
Yeah. Do you also call it if it compiles it works? Because we do that in Elm all the time.
Yeah, I mean, it's subjective and I'm biased, but I definitely feel that way. Yeah.
Yeah. Yeah. I'm guessing there's also the bias, like, well, I'm a senior engineer. I have experience, so of course it's going to work because I do the right things. But does it also work for a junior? Well, maybe.
Yeah, maybe, yeah. Yeah, there's lessons to be learned in order to get to that level, but the power is there.
Yeah. I absolutely understand the need and the longing for that kind of safety. We have it in Elm as well, and it's just amazing. Yeah. It's so hard to imagine coding without it, because I know that I'm gonna make a lot of mistakes, and I just want some tool to help me figure out that I messed up.
Yeah.
When I'm gonna mess up.
Okay, here's an interesting topic. So I'm used to doing imperative programming, where the goal is that I write code, and at the end of the day, it's machine code, and that's the transformation, targeting a virtual machine or actual machine. You're used to doing functional programming in Elm, and you're used to having certain kinds of guarantees. We both understand the guarantees, but let's try to find a bonus guarantee that you have in Elm. That I don't have in Zig because of imperative versus functional.
Yeah.
But you have to help me because you have the expert on what is available to you.
I have referential transparency.
Okay, can you explain that?
So basically when you do an operation, if you take the same code and you put it somewhere else, they will give you the same result. So doing the same operation will give you the same result. For the same inputs, you get the same outputs. That is only true if you don't have any side effects or side causes, like accessing global variables, mutating them, making HTTP calls, things like that. Because in Elm, you don't have imputations, you don't have side effects. Everything is just pure computation. Based on the inputs and based on constants, you're always going to get the same result for the same input. And that can give that can make some simplifications a lot easier. For instance, if you do, if f of 0 is equal to f of 0, then do something. Well, in a functional language, or at least a pure functional language, don't care what f is. We don't care about the implementation. We know that it's one function with the argument 0, and we compare it to the same function with the same arguments. So we know those are always going to be equal. So we can simplify that if expression to.
Oh, I see. At the call site, you can simplify this.
Yeah, for instance.
I
see. Those kinds of simplifications we can do. We can also move code around without caring about, well, did this function depend on this other function to be called first? So we can move it very easily. A linter can do that for us. And you can do that with imperative languages by either getting false positives or by doing a lot of static analysis to figure out whether this is okay or not to do.
But then it would only work if the programmer cooperated and wrote functions that did not have side effects, right?
Yeah, or you would have false positives. But you could also have the linter be very smart about it, do a lot of extensive research, like, does this function have any side effect? Does it access global variables that the other function also does? And that is very, very tricky to do, I think. I haven't tried it, but I think in some cases you will reach some missing information. For instance, it's using a function from a dependency. If you don't know what the code in the dependency is doing, then you don't know. Can you call that function twice in a row without having any weird effect?
Yeah.
We don't know. Therefore, we have some missing information. And when we have missing information, you either have false positives or false negatives.
Yeah. I think that the bulk of imperative code, I'm trying to think when it might apply to this scenario or not. I think the bulk of imperative code would have a, not necessarily a global variable, but all of these functions, let's say A, B, C, D, E, F, or whatever, they'd be methods. So they would all take as the first parameter a mutable pointer to some shared state, which effectively acts as a global variable. But it's not global. But the sequence of function calls is these methods are basically operating on an object instance and mutating it, and that's kind of the only mutations. So if we were able to
in functional programming or in
imperative,
okay,
yeah, I think that if we were able to model these as if these mutations were able to be modeled, then we could have these kind of abstractions of. I don't know what's the purposes for optimization or for linter warnings or something.
The use case I'm thinking of is simplifying code. Like,
oh yeah, you gave the example with map, right?
Yeah, if you do list.map on a list, and then you take the result of that and you call list.concat, which is like a flat map, concat map, then you can just use list.concat map instead in Elm. And you have multiple of these similar transformations that you can do. But if you care about if the order of operations matter, then this can be a potentially breaking change in the sense that it will break your code.
Right.
Like I know that OCaml is a functional language, but it doesn't have purity. So, for instance, whenever it tries to do list.map, it will always try to keep the order of the individual function calls the same. So we call list.map with a function f. Well, we call f of the first element, then f of the second element, and so on and so on. And they have to keep that order, otherwise the code might change.
Right, because
the behavior might change.
Is allowed to rely on that property. Yeah, understand.
And if you have a pure functional language, then move it around just like you want.
So this is called referential transparency?
Yeah, I think so. I'm not entirely sure, but I think that's it. Given the same inputs, you get the same outputs.
Yeah, well, I mean, that's the essence of a pure functional language, right?
Yeah.
Yeah, well, I enjoyed exploring some of these ideas with you. I'm definitely walking away from here rethinking some of my conclusions about the role of linting in the Zig compiler. So I appreciate that.
Yeah, I really enjoy this talk as well. And maybe you will make Zig a functional language soon.
Thanks for your time.
Yeah, thank you too.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.